Hello and welcome to Office Hours with Bill Jennings from Klamath Community College. Today we're going to work on a histogram and let's go ahead and just get this thing started. So how long is a 3/4 inch screw? Our author has gone out and purchased a bag of 50 screws and went home and took his calipers out and measured how long they were, and we want to try and chart this to see exactly how long is a 3/4 inch screw. Now, in order to understand this problem, how to even get started, we need to understand how to create these lower class limits, upper class limits, these boundaries, and we're going to let Excel do all the counting for us. So I'd like to explain this with a number line. We have these screws that are measured to be the first one measured is 0.722. Now I would like to consider the fact that this is from measurements for continuous versus discrete, and so it's actually quite possible that this screw that says it's 722 is actually 0.7224, because when you measure something, it's only as accurate as a measurement device. It kind of rounded down to 720. But I'd like to look at where that would land in this chart. So I've got a number line with 720, 721, 722. So 724 would actually potentially be a spot 21, 22, and a 4, probably a spot on our number line that sits right about there. And the reason why it gets recorded as the 722 and that goes away is because it would round down, and so we would actually just record it as being that point right there. Now let's consider another point. It would be a 727. So if somewhere on this grid there's a 727 that lives somewhere, we've got this 727. Okay, well 727, well this is 726 and 5. That actually is a point that would sit right there, halfway between 726 and 727, but we're actually going to round it up so it gets recorded as 0.727. So everything kind of shifts because this is a continuous scale, and so we have to slide things one way or another based upon it. Now the reason why this becomes really important is because of this guy right here, 729.75. So that's actually going to be a number that sits right here. Now it looks like if I said begin with a lower class limit of 720 and use a width of 10, it really looks like I'm saying let's go count everybody that goes between these two places. That's what it looks like on the surface. But what I want you to recognize is that there's this rounding factor that actually shoves things up. So like this 7295 actually rounds up to be 730, and so I have to actually be careful about how wide I make this thing and where things go. That's why we have to pay very close attention to this. Now, what really needs to happen here is this grid here needs to move. Wish that would have stayed together. That grid needs to move right there. So we end up with this grid that says you should actually go, come on Mr. Pin, come back to life. This grid should actually go here as such, because this guy here actually rounds up to the 730, and so down here on the low side I actually would have had potentially values that would have landed down in this area that needed to round up to 720. So even though something measured short of 720, because of rounding it, I might have actually rounded up. So my classes are actually going to begin at 7195, because at 7195, that's the first place something would have rounded up. Notice that I had it to 3 decimal places, but when I start talking about my boundaries, I'm going to be talking about something that's between something as low as 7195 and would go up as high as 7295, because that between these two areas is what's going to give me that value. Okay, so we got the number line out of the way, but now we have our numbers in line based upon what we derive from that number line. And then I want to talk about rounding for a quick second. 7195, we're going to basically create some intervals here that would look like 7195. We would take 7195, and 7195 rounds up, and then we want to go to the 7295, but the 7295 actually would round up to the next place. So we're going to actually put the interval notation as being inclusive and then non-inclusive on this side, and then we would go inclusive, non-inclusive, we'd go inclusive, non-inclusive, and so we would have this nice little step function, so to speak, of counting everything between 7195 but up to but not including 7295. And notice that this upper boundary in some respects gets shared with this lower boundary, because when we were talking about it on our number line, we had we would have interval notation that says, okay, at that point you'd round down, and at that point you would round up, and that happens to be right at 7295. Now, because we have recorded the information in 3 decimal places, we then want to take all of this information and put it then into our classifications in rounding it together. So 7195 actually rounds up to 720 if I allow it to go to 2 decimal places. Now the 7295, because I'm going up to but not including the 7295, that's actually going to stop at 729, because down here on this one, that's actually going to be the inclusive one. So that's actually going to round up to 730. And this one right here is going to look like 7395. But remember, we're using the parentheses, so that actually goes to 739. And then again, inclusive, so this gets to be 740, and this is 749, and so on down the line. So when I actually draw my lower class limit, it's actually going to be 720, and my upper class limit is going to be 729. My lower boundary is going to be 7195, and my upper boundary is going to be 7295, bringing those two things all together. Now, we're going to have to let Excel do some work here in a second and get these items out of the way, but you can see then the 720 that goes here. Now, this looks like we've blown it in some respects, because it said be 10 thousandths apart, and it really initially feels like it should be 720 to 730, because we see that as being exactly 10 apart. Now, the width really is what comes down the line, so 720 to 730. And how that really works is, if you think about counting, we'll count our thousands, so to speak, and we'll count to 10. Well, if 720 is the first one, so we'll go 720, 721, 722, 723, 24, 25, 26, 27, 28, and 29. If we start counting at 720, 10 counts down is 729. And that's one other way of thinking about it, especially when you get into integer numbers and a problem that's not as difficult maybe as this one that's got that. Let's get rid of some of this ink and let's let Excel do the work for us. Okay, so I've left a couple of our notes here on the page so we can start typing some things in Excel and make some good sense of it. So you could say that we have a lower limit and an upper limit. And with those upper limits and lower limits, let's give us just a little bit more room with that. That lower limit was 0.720, and that upper limit was 0.729. And we went through quite a bit of an explanation of getting why that is not 30 up here. But the 730 is going to go here, and you could force that 0 to stay in if you wanted to, and 0.739 here. Now I'm going to then look over here for this boundary, and this upper boundary is going to be really important to me. So this upper boundary then is that rounding point, and that's this guy right here that was sharing, because we had this interval notation that was the parenthesis on this side and the bracket on that side, and so that's where it's going to share, so to speak. An upper boundary becomes a lower boundary on the other side, because that's right at that tipping point of our step function. So 729.5 is that rounding point, and then here this is going to be 0.7395. Now remember that this class width of 10 right here, we can see it happening, that everything is 10 thousandths apart, or 100th, depending on how you want to read that number, right on down the line. So now I'm just going to go ahead and let Excel do a nice little smart fill down. That's not going to, it looks like it did what I wanted it to do. So I end up with my my upper limits, lower limits, and boundaries. Now let's go ahead and let Excel do counting for us and then create a nice chart for us. So in Excel, on the data ribbon, there's a data analysis tool here. If you do not have the data analysis tool, you will find it by going over to the file feature, going to the options, and looking for an add-in. And on the add-ins, if you click on the add-ins, it'll let you manage your Excel add-ins. Hit the Go feature, and you want to make sure that checkbox right there is checked for you, and that will allow you to use the analysis tool pack. Mine's already checked. I already have that feature added. If you didn't see it there, that's how you would add it in. On the data analysis tool, we want to create a histogram today. So we'll let the histogram tool come to work for us. We'll click histogram and then OK, and it will bring up this dialog box for us that we can now input our data and what we want it to do. Input range is just our data, so our 50 collected items. If I highlight on here, if you want to type in the cells, you could type in A1 colon A50, and you'd gather all that data there, or I can just come over here and highlight and drag down and make sure I get all of my data items. And so I could have just typed in A1 colon A50. That would have also functioned just fine. Now, in the bin in Excel is where you want to put your upper boundaries, because I don't have any data that actually is 729.5. All my data is actually to 3 decimal points. My bin is to 4 decimal points. I'm not going to have any problems about asking Excel, you round up or you round down? How is it that you do this rounding? And so the bin is a label for the upper boundaries, basically saying Excel is going to create bins. It's going to go collect the data and it's going to stick it in each bin based upon falling between these values that you have chosen. And so that's what the bin does there. I'm going to go ahead and put my output right here on this sheet. If you want your output to go in a separate worksheet, you can just let it be that. I like to put it all in one place. When you click on the output range, notice that it highlights the top cell, meaning that's the hot cell. If I click on the chart, it's going to change things, and I'm going to have to go back and re-put in the input range. So click here first, make sure you're actually putting the output range where you want it to go. And what the output range is basically saying is, where do you want to put it on the Excel spreadsheet? And where I want to put it is right there, and when it actually does the output, you'll understand why I chose that location. And then this time I want to make sure I hit the chart output, because I want to actually create that histogram that we were looking for. So we'll give it the OK button and see what happens. On the OK button, we end up with Excel giving the bins, giving the frequencies. So basically what Excel told me was I had 5 items that was 720 to 729, and I already had organized these in such a fashion that I could actually look at that. There was actually 5 of them. I put them in order. There was 5 of them that do look like that. And in reality, what I'm looking at is what was between my boundaries there. So I end up with this histogram, which is very nice. Now the labels probably should be cleaned up. It just puts the word histogram here. If this is for a technical report, making this for my boss, I'm not going to want to know it's a histogram. I want to know what it is. Measurements of screws, of 3/4 inch screws. So there we have it. It's now nice that way. I probably don't need to know this frequency because I only have one series of data on my chart. I'm going to go ahead and get rid of that. Now, I'm going to make it a little bit bigger so I can actually see what this chart is telling me. Now, on the left-hand side, it shows me the frequencies. It says, hey, you had 5. But this label down here on the left is a little bit off. It says, if I was to hand this to my boss, I don't think that my boss could actually read this. And there's a little bit of an issue with that, it feels a little bit off. So what I'm going to do, what if I click on this chart, you'll notice that on the chart you'll see that this is being highlighted and that is being highlighted. This is the frequency and this is the bin, and so what actually is typed here is actually what sits right here. If I change this to be the letter A, you'll notice that that becomes my new label of this chart. So what I really want to do here is I want to type 720 to 729. And if I type that, that's actually what's going to go there. And that actually is something that would be very useful to me as a label. And I'm going to go ahead and fill those down. Okay, so I went ahead and finished filling those in for us so we could actually see what we have going on here. Now, all I had to do really there was just change that value, and it sits over here. Now, this is much more meaningful to the reader of this chart in meaning that it's 720 to 729. There was 5 that was between it. If I just put that bin there, I don't think the reader of the graph is actually going to understand what we have going on. Now, the other part, too, is this word bin. I don't know that that would be really a good measurement. I'm going to talk about this being inches, because that's actually what I measured was inches here. Is how many inches in decimal form. Now, the other piece that's really not perfect about this histogram is that these bars should be together. This gap makes it look like, to me, like I had 5, and then there was a space that there was like this big gap that there was no measurement, and then there was no count, if you will, no count, and there was all of a sudden there was 11 of them, and then a gap with no count. I want to get rid of that gap. There's 2 ways that we can get rid of that gap. One way that we can do it is up here on the chart tools. If you click on the chart tools, so if all I did was click on that green area there, there's a quick layout feature. And on that quick layout feature, you'll notice that you can scroll through and you can see what these things are going to look like in all different shapes and sizes. And look at this one right here. That actually puts those bars all together. Now that's one way. That's the quick layout way to fix that, to make that come together. Now the other way that we could do it is to right click on the bar itself and give it a format issue. And so if I wanted to format this data series, I'll get an option box over here on the left, and in between this writing here that we don't need anymore, I'll get rid of that. You'll see that we have this gap width that says gap width is 150%, and I could make it wider if I wanted to, or I could make it go to 0, and that's actually what I would be looking for. Now, a lot of people also like to finish it up and make it a little bit cleaner by putting some lines on it. You can do that right here on this outline. You'll notice that the color is blue. You can change the outline to be black, and then I would then have this nice, beautiful graph. Now, this is something I could put in a technical report. I could take it to my boss. Everyone would be able to read it to understand what happened. If you look at this output, I think you'll find that this is something that's actually very readable to the user. If you just take that automatic one that came in, it leaves the bin numbers. Very hard for our reader to use. Unless you've taken a statistics class, you're not going to be able to read it, and not everyone has, and we want to make our graphs work for everyone out there. Thanks for watching the video, and we'll see you on the next one.